So in this video we are going to discuss about the string matching algorithms. There are multiple string matching algorithms that we use. There are string matching which is a naive string matching algorithm. Then a part of naive string matching algorithm we know there's a Rabin-Karp algorithm. Then we have finite automata based algorithm, and after the finite automata based algorithm we have the algorithm which is KMP, that is Knuth-Morris-Pratt algorithm. In this name, this was the name of the scientist, that is Knuth, Morris and Pratt. So we are going to discuss all these three algorithms. So let me write the name. The first string, the topic name is string matching, and in this string matching topic we are going to study the following algorithms. Number one, that is the naive string matching algorithm. The naive string matching algorithm, and after this naive string matching algorithm, next one is the Rabin-Karp algorithm. Rabin-Karp, and then we'll study finite automata based string matching, finite automata based, and the fourth one will be the string matching which is based on the Knuth-Morris-Pratt. Knuth-Morris-Pratt, that is KMP algorithms. So here why we introduced these many different algorithms, because each and every one of these algorithms is doing some kind of improvement as compared to the previous algorithm. Like we have the naive string matching. Now this Rabin-Karp algorithm reduced some improvements over the naive string matching. Then we have finite automata, and the best one is the Knuth-Morris-Pratt. So first of all, you need to know why we are studying the string matching algorithm. Why is it so important, and what is the main benefit of string matching algorithms? If you see some of the web browsers, like if you check a web browser like Firefox, right? Or maybe there are a lot of applications of string matching algorithm. Web browser is just a very simple and easy to use applications which we use in the daily life. A part of web browsers, there are so many different applications which are also there. Now in web browsers, you see in the address bar, when you write www.google.com, or even if you write for Facebook, even if you write face, now it automatically suggests some websites. It automatically suggests Facebook, or maybe FaceMash or whatever. Some websites are there, so it automatically suggests some of the websites and it do autocomplete, right? And how does it automatically suggest these websites? Here, if you have only written face, now it is looking face, or it is finding face as a substring of the given string, right? So here you can identify it like this. In case of string matching, we'll be having two things. Number one, we'll be having a text which is which can be a very huge text or very large text. Maybe the text is like this: A B A C D B B D C A C B A D C B, something a very large text, and we'll be having a pattern like this. Okay, so assuming this is a pattern, so pattern is A B C D. Okay, now this pattern may be present in this text or may not be present in this text. For example, assuming in this text we have the following pattern. Okay, so here you can see this pattern is already present in this text. And this text is actually stored in index locations like this, because if we know in case of C language, the strings are array of characters, so it is just denoting the array of characters like this. In the same way, the second string is also denoting array of characters. Now our job is to find this particular pattern in this particular text, and if you want to find this particular pattern in this particular text, then it can be very easy. That means you can implement a very easy algorithm which is a brute force algorithm, or sometimes it is also called as a naive algorithm, to search this pattern. But the time complexity for the brute force or the naive algorithm is more as compared to the other algorithms. So we introduced the other algorithms to kind of to improve the time complexity to search the following pattern onto the text. For example, if the length of the text is n and the length of the pattern is m, the most simplest algorithm that you can propose, the most simplest algorithm, that is the naive, or you can say the brute force method, that means where you are going to check every possible combination. Now that simplest algorithm is going to take order of n minus m plus 1 as the time complexity. But our aim is to find out, can we do something better than this? Okay, so let us do one thing. I'll start with the naive algorithm, and before this, I think you understood the problem. What is the problem? Problem is like this: there's a given text, and this given text is containing so many. It can be having any length, right? And that length can be very huge, and there's a given pattern. Now we need to find whether this given pattern is present inside this text or not. Now if this pattern is present inside this text, then we have to give, or we have to return the starting index location of that particular pattern. Okay, so you need to implement this algorithm, and do one thing: pause the video, or go back to programming and try to implement, but where a C program, or even if you prefer Java, or even if you prefer C++ or any programming language, because in case of Java we already have some kind of built-in functions. Even for in case of C and C++, we have built-in function to find a substring. It is kind of a finding a substring. There already functions are there, but I want you not to use those functions, but rather implement your own technique to find out whether this given pattern is present inside the text or not. If you can implement your technique, then we can further improve it, and we can further see how many different types of algorithms can be proposed to find out this pattern. Okay, I think you understood what is the problem statement. Now just go back to your programming and give a solution to this problem statement. Okay, so here I'm going to start with the first brute force technique, that is the naive algorithm. Okay, so let us start.